Boys and girls, this is Mr. Manise here again with another super cool video. And in this video, I am going to walk you through each of the problems on our quiz review for advanced algebra for z-scores, percentiles, margin of error, confidence intervals, and sampling methods. So my disclaimer is always on these videos is I need you guys to actually work through the problems, see what you can do on your own, and then if you can't figure out a problem or you have a misunderstanding, then come back and watch the video and see if you can iron out your mistakes or any misunderstandings that you may have. Okay. All right, so let's go ahead and jump right in with number one. And before I do that, I want to pull over this sheet here because I think I need to kind of hammer this point home. We've got our traditional bell curve here. When we first learned about normal distribution and the empirical rule that said that 2/3 of my data, about 68% is in the middle, within one standard deviation of the mean, and then 95% of my data is within two standard deviations, and then 99, almost all of my data, 99.7%, is within three standard deviations, assuming that the data is normally distributed. You got to remember, guys, these percentages here, the 13.5% and this 19 and this 95%, these are approximate values. This is what we would anticipate, what we would expect if the data is normally distributed. Okay, so if you tell me I'm sitting here at exactly -1 standard deviation on the low side, I'm sitting here at 1 standard deviation on the high side, I would anticipate that would catch about 68% of the data. The z-scores, guys, are a much more accurate estimate of what's going on. Notice the z-scores are rounded to 4 decimal places, whereas pretty much everything else we do is rounded to maybe 1 or 2 decimal places. Okay, so just keep that in mind. Z-scores are more exact. So when I look at this first problem here, we're talking about IQ scores. The normally distributed with an average, okay, that's our X bar, average of 100 and our standard deviation of 15. There's our sigma there, okay, our standard deviation. In a random sample of 9,000 people, approximately how many people will have an IQ between? Okay, when you guys see that trigger word, always got to look for these trigger words in math, especially statistics. Between 85 and 130. Okay, I'm trying to capture the data between both of those numbers. Now, if you'll notice, if I've got a standard deviation of 15 and an average of 100, if I pull back this chart and make a separate little chart for this particular problem here, just kind of sketch it out real quick. I've got an average X bar of 100. I'm sitting there with a standard deviation of 15. If I'm at 85, isn't that just -1 standard deviation on the low side? Okay, make sure you guys can see that. And then I also want to know between 130. Okay, well there's 15 on the high side. At 1 standard deviation would be 115. And then sitting there at 2 standard deviations, I'd be sitting at 130. So some of you guys may look at this and say, okay, I'm basically just trying to capture the data between -1 and 2 standard deviations. And you're right. And you can use these numbers to get an approximate value. Okay, I could say, well, between -1 and 1, that's 68% of the data. And then I can tack on this extra 13.5, 13.5. So if I add those two numbers together, 68 plus 13.5, that gives me 81.5. So essentially, I would anticipate that 81.5% of the values, the IQ scores, would be between 85 and 130. Now, on the test and the quiz, guys, if you do that, if your standard deviations are nice, pretty round whole numbers, you can do that, and I'm fine with that, and I will count that correct. However, you might not, the question might not be so nice to you. You might not have this nice, pretty standard deviation, okay? So in that case, whenever I see this, but me, just kind of the engineer coming out of me, I want a much more accurate precise answer to the question. So I'm going to use z-scores. So what I want you guys to remember is when you see the word between, you need to get the two z-scores for these raw data points, and then you're going to subtract them. Okay. So the first thing that I'm going to do is I'm going to calculate the z-score for 85, and as you might anticipate, we kind of already know what these are, but let's go ahead and calculate them anyway, so maybe the kind of the light bulb goes off. The z-score for 85, okay, the formula, let me write this up here. Z-score is going to be equal to the raw data point minus the average, the population mean, or in this case the sample average, over the standard deviation. Okay, so that's going to be equal to our raw data point, which is 85, minus the average, okay, which is 100, divided by the standard deviation, which they told us was 15. Okay, so if we do the math there, that comes out to be -1. Well, what do you know? Isn't that the same thing we said over here? We're sitting here at a -1 standard deviation, so we pretty much already knew that. Okay, the z-score for the 130 is going to be the raw data point, the 130 minus the average over the standard deviation. Now, by the way, I also wanted to point this out to you guys. If you're doing this on the calculator, in this case, of course, you could just do this in your head, but if you're typing this on the calculator, you've got to put that numerator in parentheses, because watch what happens when I type in 130 minus 100 divided by 15, order of operations, right? That's not going to give me the same number. If you're trying to do that in all one swoop here, you got to put that numerator in parentheses. And of course, we know that gives us a standard deviation of 2, okay, which is, again, is what we already kind of saw visually here. I'm between -1 and 2, okay. All right, so now that I got the two z-scores, I need to go to my z-score table and actually get the percentages, okay. Now notice, guys, on the z-score tables here, you've got to pay attention. You've got a negative z-score table, and then you guys is front and back, but I printed this out separately, and then you got a positive z-score table. You've got to make sure you're looking at the correct side. So starting out at -1, I need the negative side, okay. So once again, just to clarify how we read these z-score tables, the z-score is over here on the left. These are rounded to the 1 decimal place, to the tenths. Everything up here going across the top is rounded to two decimal places, rounded to the hundredths, okay? So we've got a z-score of -1, okay? So I'm simply going to come down here until I see -1.0, which is that guy right there, okay? There's my 0.0. I don't need to look over here in the top because it's just -1. So I'm simply looking at this percentage right there. Remember, guys, all these numbers in the z-score table, these are all percentages, okay, based on your z-score, which is the standard deviation above or below the mean. Okay, so this is going to correspond, this -1 is going to correspond to a 0.1587 percentage. Okay, of course, we move the decimal place 2 spots, that would be 15.87%. The z-score for 2, for the 130 over here, now I got to look at the positive side. So I'm simply going to go up to 2.0, and I'm looking at that guy right there, okay, right here, 2.00. All right, so 0.9772. 0.9772, okay. All right, so now it says between. So I'm going to go get my two z-scores, go to my table, get my two percentages, and I'm simply going to subtract these numbers. So 0.9772 minus 0.1587, and that gives me, type that in your calculator, and that gives me 0.8185. Okay, so let's stop for a second. Wait a minute, let's stop. When we went back over here with just our normal distribution curve, we said, well, shoot, if I'm at -1 and 2 standard deviations, I just add these two numbers, I'm sitting here at about 81.5%. Notice that when we went the z-score route, we didn't get 81.5%. We got a more exact answer. We got 81.85%. Okay, so I want to make sure you guys understand that connection there. All right, so now, but that's not what the question says. The question doesn't say what percentage of people have IQs between 85 and 130. They say how many people. So I have to take this percentage, 0.8185, okay, or that decimal in this case, and I need to multiply it times 9,000 people. Okay, so if I do that, that comes out to be 7,367 people. Okay, if you use the 81.5 number just from our normal bell curve, then you would have gotten a number a little bit different, a little bit less than that. Okay, either one is fine with me. I would prefer for it to be exact, but I won't count it wrong if you use the regular curve in those approximate percentages. Okay, let's move on. SAT scores are normally distributed with an average. Okay, there's my X bar of 1980, standard deviation of 280. There's my sigma. Find the percentage. Okay, now I don't want a hard number. I actually want the percentage from the z-score table. Percentage of scores higher, guys. There are those trigger words, higher. Higher than 2100. Okay, so the first thing I got to do before I find percentages, I got to go get my z-score. Where are we on the curve? Are we where's our z-score? Remember, z-scores are just standard deviations. Am I sitting here at 0.7? Am I sitting here at a standard deviation negative 2.39? You know, where am I on the curve? Okay, so I'm going to use my z-score formula. My z-score is going to be equal to the raw data point, which is what I'm after, the 2100, minus the average. That was this guy up here, minus the average, 1980, divided by the standard deviation of 280. Okay, type that in your calculator. That comes out to be 0.43. Okay, there's my z-score. All right, so I'm sitting here on the curve. I'm sitting about right here, 0.43. Okay, now let's go find out which percentage is higher than that. Okay, so I've got to go to my z-score table. I'm looking at the positive side because I've got a z-score positive 0.43. Okay, well here's my z-score. Here's 0.4. Okay, but it's 0.43, so I've got to go over here to the hundredths place, to 2 decimal places. And guys, you're going to have to bear with me with my webcam. Sometimes it goes out of focus, so just bear with me. Okay, so 0.43 would be here, and then I just come down and find this value in the table, okay, which is, in this case, 0.6664. Ugh, that's not very good. 3 numbers there, okay. All right, so anyway, so this corresponds to a percentage of 0.664, okay, but it says higher. Remember, guys, when it says above, higher, more than, okay, so if we're sitting here at 0.43, I want all these people. I want all these people higher than that, okay, to the right. So when I'm looking to the right, when I'm going this way, I'm looking to the right of my curve. You must take this percentage, you must subtract it from 1. Okay, so it should be 1 minus 0.664. Okay, that comes out to be 0.3336. Okay, but I want a percentage, so just move the decimal place 2 spots, and we get 33.36%. Okay, let's go again. Find the percentage of scores lower than 1850. Z-score is my raw data minus the average over standard deviation. That number comes out to be negative 0.46, and I would expect that, right? Because my data is less than the average. So that means I'm to the left of the mean. So I would expect a negative standard deviation. That makes sense. All right, so let's go to our z-score table. I'm looking at the negatives now. Negative 0.46. Okay, there's negative 0.4. And then I'm going to scroll over here. You guys can't see that very well on the camera. Scroll over here to the 0.6. So if you follow that, I'm sure y'all can see it on the video. Negative 4.46 comes all the way down to that value right there, 0.3228. Okay, so that corresponds to 0.3228. But notice it says lower. I want all the values to the left of the curve. So when I'm looking to the left, when you see the words lower, less than, under, then you find your percentage and you're done. So the answer is 32.28%. That's all you got to do. Okay, part C. Here's that word again, between. Okay, when I see the word between, that ought to be a red flag. Hey, 2 z-scores. Okay. All right, so I got to find the z-score for 1450, and that's going to be 1450 minus the average over 280. That comes out to be negative 1.89. Okay, so unlike number 1, we don't have these nice, pretty standard deviations. Okay, so when I have a z-score like this, and I'm going to have to use the table. The z-score for 2450 is going to be 2450 minus the average over the standard deviation. That comes out to be 1.68. Okay, so I got the z-score for the 1450, the z-score for the 2450. I have to go to the table. I'm going to say use the table, and I need to get the percentages for both of these guys. Okay, let's start with the negative. Negative 1.89. Okay, there's the negative 1.8. And I got to go all the way over here to 0.9. So I'm going all the way over to the right side of my table. And that should give you this value here, 0.0294. 0.0294. Okay, now I got to find the percentage for the 1.68. Okay, here's 1.6, 1.68 is going to be this number right here, 0.9535. Sorry, y'all can't see that. Come on, there you go. All right, so that's 0.9535. And then we subtract the two percentages. So 0.9535 minus 0.0294. And that gives me 0.9241. And of course, that corresponds to a percentage of 92.41%. Okay, so guys, remember, ask yourself, do these little quick gut checks. I'm always a big believer, does my answer make sense? So think about that number for just a second, because I know, I can feel it in my bones. I know that there are going to be some students that reverse the higher and the lower. They're going to get these backwards, and they're going to leave that one, and then they're going to subtract this one from one. They're going to get them backwards. But think about your answer. If I'm sitting here at between 1450 and 2450, if I'm sitting at a negative 1.9 standard deviation or 1.68. That's almost -2, and that's close to 2. So isn't that about 95% of the data? Yeah, well, we're not at 95%. We're a little less than that because 1.68 is not quite 2, and that's not quite -2. Okay, so ask yourself, does my answer make sense? Okay, if I'm sitting here at a standard deviation of 0.43, okay, doesn't it make sense that the data to the right of that is going to be, it's got to be something less than 50, right? Because if I got a z-score of 0, I'm sitting right in the middle. So something 0.43, because if you don't subtract this from 1, if you made a mistake, your final answer would be 66.6% of the data. So what you're saying is, you're saying I'm sitting here at a z-score of 0.43, and all the data to the right of that is 68%. Okay, you're saying that 2/3 of the data is just over here on this little part over here. Okay, so use some common sense when you get these numbers. Ask yourself, does that make sense? Do I buy my answer? Okay, number 3, I ran a sample of 50 high school students. We're asked to estimate the amount of time spent on the phone every night, which is probably about 12 hours for a lot of you guys. So the mean of all GHS students was 1.74. Okay, there's the average, X bar, with a standard deviation of 0.4. So there's my sigma. Assuming a normal distribution, guys, none of this stuff works. None of it, not a lick of it works if the bell curve is not in play, okay, if it's not normally distributed. Empirical rules out the window, z-scores, all that stuff's out the window. What is the probability? That just means percentage. What is the percentage that the time those students spend on the phone every night is less than, there's that important phrase, less than 1.65 hours? Let's go get the z-score. The z-score for 1.65, okay, and that's going to be equal to my raw data value, 1.65 minus the average. Okay, that's our average of 1.74. So already it's less than the average, so I know the z-scores are going to be negative, divided by the standard deviation of 0.4. Okay, type all that in your calculator, and you get -2.25, which is kind of what I was anticipating. Okay, so we're kind of pretty far off to the left of the curve. All right, so now I've got to take this and let's go find our percentage. That's a negative, so I'm going to go to the negative on the table. All right, so we got -2.25. There's -2.2. Here's the 0.5, so that's going to correspond to a percentage of 0.122. Okay, so that is okay, -2.25. Let me make sure I'm doing this right. Okay, so I have, that comes out to be, let me make sure I did the math correct on that one real quick. 1.65 minus 1.74 divided by 0.4 Aha. That's what it was. I thought there was something wrong there. See, I caught myself. That comes out to be negative 0.225. I knew something wasn't right there. Okay. Let me change that. Sorry about that, guys. So this is going to be negative 0.225. Okay, so let's go back to our table. Okay, so negative 0.2. Okay, so I've got a z-score. And by the way, guys, we always round z-scores to 2 decimal places because we only have 2 decimal places going across the top. So this is really negative 0.23. Okay. All right, so let's go to negative 0.23. There's negative 0.2. Here's 0.3. So that value corresponds to this guy right here, 0.4090. So 0.4090. So the question is, do I need to subtract that from 1 or not? And it says less than, so I want data to the left of the curve. So when I'm looking to the left, you see less than, under, beneath, you just leave it. That's your percentage. So that corresponds to a percentage of 40.9 or 40.90%. Okay. And doesn't that make sense? Once again, I'm going to keep going back to this. Doesn't that make sense? I'm sitting here, that's almost 0.225. So on my curve, on my normally distributed curve, I'm sitting like right here. Okay, I'm very, very close to the middle. So I basically want all of this data to the left. Well, isn't that almost half of the data? Yeah, it's almost 50%. So that's why, yeah, I buy that answer. Almost 41% or so. I'm close to the middle. Okay, here we go. Margin of error and confidence levels, confidence intervals. Okay, guys, there are only 2 things you need to remember with this, margin of error and confidence interval. When it asks for the margin of error, all you're going to do is you're going to plug it into your margin of error formula, and that is your z star, which I will give you that value, times the standard deviation divided by the square root of the number of samples that you have. That's just plugging in numbers on your calculator. That's going to give you an answer, plus or minus 2.6, plus or minus 12.3 hours, or whatever we're talking about, okay? So that's all we're doing here. With a 95% confidence level, the z-star value that I will give you is equal to 1.96, okay? So when you plug this into the formula, I've got margin of error is equal to 1.96 times the standard deviation, which is going back up here, times my sigma, divided by the square root of the number of samples. Okay, well, we've got 50 high schoolers. Okay, so square root of 50. Okay, plug that into my calculator. 1.96 times 0.4 divided by the square root of 50, and I get 0.11. We can just round it 2 decimal places there. Plus or minus 0.11 hours. That's our margin of error. Okay. All right. So now when they say write a confidence interval, now that says, I had you guys scratch this out. I wanted you to do it on a 99% confidence level. So when they say find the confidence interval, they want you to take this margin of error, and all you got to do is add it and subtract it from the average. Okay. So I'm going to take this plus or minus 0.11 hours, and I'm going to add it and subtract it from our mean. Okay, so your interval, I'm just going to say CI, confidence interval, is equal to the X bar and then plus or minus your margin of error. Okay, that's just a little way to think about it. So I'm going to take our average, so 1.74, and I'm going to add the margin of error. I'm going to add 0.11, and then that's going to give me, that gives me 1.89, and then I'm going to take our average and I'm going to subtract the margin of error, and that gives me 1.59. Okay, so there's my interval. I'm going to say, remember, the whole reason of doing all this confidence interval and confidence levels, we don't know what the population mean is. That's what we're trying to find. Normally they give us mu, and we know what the whole average is. Okay, but this time I'm pulling a 50 high schooler so that I can figure out, okay, I want to say I'm 99% confident that the average time that a student spends on their phone every night is between this value and this value, okay? So I'm going to say that the average hours of phone usage per night is going to be somewhere between 1.59 hours, there's our unknown mu, and less than 1.89 hours. There's my confidence interval. I'm 99% confident that that actual average based on this polling of 50 students is somewhere between 1.59 and 1.89 hours. Okay. All right. So hopefully you guys are okay with that. All right, number 4. Okay, all the sampling stuff, guys. Simple sampling is easy. That's just randomization. That's what I do on my iPad. I assign each of you guys a number, and then I use my iPad to randomly call on you. That's simple random. And you got systematic, where you're pulling every 10th person who walks through the door, or you got a car part assembly line in a manufacturing plant. You're pulling every 100th part off the line, and you're checking it. That's systematic. Stratified and cluster. I find that students sometimes get those confused. So let me kind of explain that. Stratified is where, stratified is where you've got a big group of people, okay? And then you're going to divide that big group of people into, or big group of something, into smaller groups, okay? And then from each of these subgroups, and you're going to do this based on some characteristic, okay? So maybe we take Greenbrier High School students, and we separate them into, what is your favorite hobby? Music, sports, computers, games, something like that. And then from those groups, I'm only going to poll 100 people. I'm only going to poll 100 students, okay? That is stratified. You've got a large group. You break it into smaller groups based on some specific characteristic, and you only poll some of the group, okay? Cluster is the groups are already pre-existing. I already have these groups, okay? So say we're talking about sports. We already have those groups. I already got football. I already got basketball. I already got tennis, okay? And then cluster, all right, cluster up here. Cluster is you're going to poll the whole group, the entire group, whole group. I'm going to go ask all the football players. I'm going to go ask all the basketball players, all the tennis players, okay? That's the biggest difference between cluster and stratified, okay? So hopefully you guys are okay with that. All right, so let's look at number 4. A survey is conducted at Riverside Middle to figure out which school lunch choice students prefer. Every 5th student, well, there you go. Okay, that's a dead giveaway. Every 5th student who walks in the doors asks a question regardless of race or gender, and that's going to be systematic. Every 10th one, every 5th one, okay? Mr. Seagraves, yes, I know. I guess we need to change this to Miss Shelton from now on. Miss Shelton has a question for students concerning discipline. She knows that students are already divided up into homerooms and decides to take all of the math hall homeroom classes to take a survey. They're already divided up, okay? That's your cluster. Okay, we already have our groups, and we're going to ask everybody, okay? So that is going to be clustered, okay? If she said that we're going to take these groups and we're only going to poll some of the homeroom classes, that would be stratified, okay? All right, so hopefully you guys enjoyed this video. I hope this cleared up any misunderstandings that you may have, and I wish you guys the best of luck on your quiz, and we will see you on the next video.